All right, so we would like to prove this corollary, which describes curvatures, Gaussian and scalar curvatures, in terms of the quantities E, G, F, and L, M, N. And to do so, we use these equalities, which we proved in the last hour, and also the equality, the identity called Lagrange identity. And we do the following. Take the dot product of the equations 1 and 2. With the normal vector, V cross W to get, okay, so okay. Now the Lagrange identity is this, right? I have two vectors here, their cross product with W dot product with W cross V, and it is equal to that gadget. Now I will let this X, for example, SV, and this Y SW. Okay.
Yıldır hocam pardon, sanırım ekran dondu.
Evet, ekran gene donmuş.
Teşekkürler hocam.
Okay. So let me go over this again. In the Lagrange identity, I have this X and Y. I will let X and Y X sub S of V and S of W. And S of V and S of W, their cross product is equal to this gadget. So, okay, then we have the following. Let me just write down what we get. Okay. So S of V cross S of W dot product V cross W. This is by the Lagrange identity. This is X, this is Y. So S of V dot product V, right? S of V dot product with W, S of W dot product V, and S of W dot W. Now, what is S of okay. Yeah. And okay, it is equal to this one, but this gadget is also equal to what? This is equal to S of V cross S of W by 1. It is the Gaussian curvature times V cross W. So instead of this, I write this, and then here again I have this gadget. So that's equal to what? Gaussian curvature times, I have dot product of these two cross products. So it is V cross V, V cross V dot W, W dot V, and W dot W. Now these are equal to each other. Hence, kappa P is what? This determinant is equal to this determinant. So kappa V is just this guy divided by this guy. So SV dot product V, SV dot product with W, SW dot V, SW dot W divided by V cross V dot V, V dot W, W dot V, and W dot W. And what was the definitions of these expressions? This was by definition L, değil mi? Onları nerede tarif ettik? Okay. L was S sub U dot product S sub U. Well, in this case, okay, I don't have U but V, doesn't matter. So this is L, M, this is M, this is M, and this is N, right? Yes. And this is E, this is F, F, and G. Here, of course, where V is X sub Q and W is X sub V. Okay. Yes. So so this V and this V are not the same. Yeah, yeah, yeah. V and W are the linear algebraic terms here, right? Yes, yes. So they are not the same. So it is kappa P then, it is L n minus m squared divided by EG minus F squared. For the other one, for HP, HP, I should say. Okay, so here it should be HP, not X. I wrote somehow X. Okay. For the second gadget, you do similar things. I will leave it as an exercise. So what you do, again, you take dot product of this with So to prove this one, again, we will do this similar computations. We will take dot product of both sides of this equation with the vector v cross w, and then use Lagrange identity. Okay, but I will not do that. So the second is an exercise. Okay. All right. There is some remarks, maybe one remark. Since u is a normal vector, to M, and x sub u is a tangent vector. U dot product x sub u is 0, right? Tangent vector and normal vector always are perpendicular to each other, right?
Yıldır hocam pardon sanırım kamera diğer tahtada kaldı.
Özür dilerim.
Teşekkürler.
Okay, so I left the second part as an exercise. And we have this remark. If you have a surface, then of course, this is the normal vector, let's say, and we have x sub u and x sub v tangent vectors. U is perpendicular to both of them. So we have this 0, which is the derivative of 0. This is 0. I take derivative of this with respect to xv. So along the direction xv. So what you get is derivative of this expression along v, dot product x sub u plus u dot product x sub uv. I mean, here I should say v, right? Okay. And what is this expression? What is this expression? Okay. Since SP x sub v is minus x sub v u, which is just minus this derivative of u along the vector x sub v, but it is just u sub v. So we get what? We get s of x sub v is burada bir uh, okay, so this normal curvature is what? This normal curvature is this gadget is just minus u sub v dot product x sub u, but x sub v dot product x sub u is what? It is this expression. It is negative of this, right? So it is minus negative of this expression. So it is u dot this. So shape operator computed along the vector x sub v dot product with x sub u is equal to u dot product x sub uv. And I can compute the other one. Aslında sanırım buradan bariz. Şöyle yazayım. Now similarly ya da tamam. Şey yapayım. Okay. Let me erase this board. Now similarly x sub u dot product x sub v will be what? It will be u dot x sub vu, right? Just you replace the letters u and v, right? Here I have uv, vu. Here I have uv. If you change u and v, I will change u and v there. I will get this, but x is a smooth function. Therefore, this is the same as this one. Therefore, this gadget is just x sub s of x sub v dot product x sub u, meaning that so that s is symmetric. Okay. So that's the proof actually that S is symmetric. In a basis, we see that S is symmetric, therefore it's a symmetric matrix. Of course, you should go back and check, whether we actually use the fact that S is symmetric before for this computation. Yani S'in zaten simetrik olduğunu kabul ederek yaptıysak o zaman da bunun hiçbir değeri yok. Değil mi? Bunun içindeki şeyin içinde hani ispatın içinde bunun içinde S'in simetrik olduğunu kullanmadık. Onu görmeniz lazım. Okay. We have another lemma. If X is the surface patch, as usual, in M, Then L is L was x sub u dot product x sub u. It was the normal curvature along xu. This was the definition, but now we have seen that no, actually we didn't do that, but okay, we will do this. So this is u cross u dot x sub u x sub u x sub uu. Similarly, m is, which was x sub u dot product x sub v. This is u dot product uv, and L is well, I guess here you see that the Hessian of x, right, comes into picture. You have the second derivatives. Now let's see the proof. These are the definitions, right? L, M, N are defined like this. Statement is this. This expression is equal to this one, and so on. Okay, that's the proof. That's what we need to prove. Okay. Recall that we have for any curve, right? Unit speed curve, we had this. Alpha double prime is equal to the value of the surface operator at the tangent vector alpha prime dot product with alpha prime. And this was the normal curvature along the vector alpha prime. Now let's just apply this to hence L, which is by definition. So what is this? So I take this as my alpha prime, S of alpha prime times alpha prime. So that is just alpha double prime. Sorry, alpha double prime. Yeah. Okay. Maybe I have to be a little bit more careful. Let's do this. Okay. Let alpha t to be this. X up u plus tv. Okay. Then alpha prime is just x up u, right? And what is alpha the x up u plus t v, and what is the second derivative? You take derivative with respect to t again. There is no t here, so this is x up u plus t v. So when I plug 0, I will get x up u, and here I will get x up uu. Alpha is a curve. Alpha is a curve. Neyse şurada yapayım. Here alpha is a curve passing through this point P at 0. And this is the alpha prime 0, the tangent vector, which is x sub u. Now, from this we see that hence L, which is S of X sub U, dot product X sub U, which is equal to S of alpha prime dot product alpha prime, but this is equal to U dot product alpha double prime. So that is equal to U dot product alpha double prime X sub UU. All right. Similarly, what is the next, the last one? Sorry, X sub V, X sub V. This time I will take the curve alpha t, not this one, but X of U V plus t, okay? So this will be X sub V and this will be X sub VV, okay? And if you do the computation, you will just get U dot product with X sub VV. The same thing. You just replace the rows of U and V. Okay. So we proved the first and the third equalities. Let's see the second one. Okay, we actually did that one also, right? The middle one, this one is what? This one is what we had done over here. Yeah. Right. So this is done in remark. All right. What else? Okay, I just have one example. Let me erase the board. Example. Ellipsoid. So it is the surface given with this surface patch, U times cosine V, U times sine V, BV, where B is a non-zero constant. Okay, non-zero constant.
Yıldır hocam, pardon, kamera. Teşekkürler.
Sağ ol. Okay, so we will do this example, ellipsoid, which is given by this surface patch, and okay, let me try to draw the ellipsoid, so it's something like this. Yani bu çok iyi bir resim olmayacak ama, so şöyle diyeyim. Okay. So surface is like this. Uh, so you have a helix and you join the helix with this axis, okay, by lines. All right. So you have this helix and you have this line, and then you join these points by line segments to the z-axis. You see here, when v is fixed, and you just change u, you move in the xy direction, right? Z coordinate doesn't change, you just move in the xy direction, right? So you get a line segment joining this point here, right? This is the point xuv, let's say, and then yeah, it goes till infinity actually. Let me say, okay, for any fixed v, for any fixed v, I have cosine u, sine u, and v. Okay, so this point, let's say, is cosine v, sine v, and bv. I just join this point to this point. What is the coordinates of this point? X and Y coordinates are 0. Z coordinate is bv. I just join these two. How can you do this? Well, you just put the parameter u here, and you let u change from 0 to 1, right? When it is 0, you are here. When it is 1, you are here. So this surface contains these lines. Okay? Merdiven gibi, değil mi? Hani bir eksen boyunca böyle merdiven gibi. All right. Now let's compute the stuff for this parameterized surface. What is x sub u? Well, it's just cosine v, sine v, 0. What is x sub v? Minus u times sine v, u times cosine v, and b. So what is E then? E was x sub u dot x sub u. So dot product of this with itself, it is clearly 1. F x sub u dot x sub v. So when you take dot product with this, you get 0, I guess. There. And what about G? X sub v dot product x sub v. So it is square of this plus this. So it is u squared plus b squared. U squared plus b squared. All right. What about x sub u cross x sub v? Let's compute normal vector. So this is I, j, and k. X sub u was cosine v, sine v, 0. And this is minus u times sine v, u times cosine v, b. And if you do the computation, let me tell you what the result is. This is b times sine v minus b times cosine v, and then u. The z coordinate is u. All right. Let W denote the length of this normal vector. It is not necessarily unit, right? What is the norm of this? So length of this vector. Karelerini alıp topluyoruz. B kare artı 100. So this is B squared plus U squared. Well, and then of course take square root. Okay. All right. All right. Then what is U? Hence, U is the unit normal vector, which is just x sub U cross x sub V divided by the length of this vector. So what is that? Then 1 over, okay, B times sine V minus B times cosine V, and then I have U here, all divided by B squared U squared inside square root. Now, we may compute the second derivatives. This was x sub U. So if you take derivative with respect to U again, x sub U, it will be 0, 0, 0, right? So x sub U is just 0, 0, 0. What is x sub UV? I take derivative of this with respect to V, I will get minus sine and cosine here. So minus sine V, cosine V, and 0. And what about x sub VV? We take derivative of this with respect to V. So it will be minus U times cosine minus U times sine and 0. So let me write minus U times cosine minus U times sine and 0. So what about the other quantities? Okay, what is, for example, L? L was x sub UU dot product with U. X sub UU is this, U is this. This dot product is clearly 0. All right. M x sub VV dot product with U. No, UV. This is UV dot product with U. X sub UV is this dot product with U. So minus sine squared minus cosine squared. So it will be just B minus B divided by this expression. So it is minus B divided by B squared plus U squared. And what about N? And x sub VV dot product U. And what is this? Yeah, that is 0, right? Minus sine cosine plus sine cosine. Yes, this is 0. Okay. All right, finally, the Gaussian curvature K, which was Ln minus m squared divided by Eg minus f squared. This is just n is 0, therefore this term is 0. M squared is just b squared divided by b squared plus u squared divided by Eg minus f squared. Eg minus okay. Eg is 1 times u squared b squared, so u squared plus b squared minus f squared. F is 0, so we get what? B squared efendim? Hangisi minus? Ha, burası minus değil mi? Tamam. Çünkü başında eksi var. Tamam. So minus b over b squared plus u squared squared. Okay. Evet. Şuna W demiştik. Neye W dediydik? Square root of b squared u squared was W. So this is just b squared to the power W to the power 4, because W was by definition this norm of the x sub u cross x sub v. Eksi, evet. So the curvature is negative, okay? Curvature is always negative. And h, which was GL plus En minus Fm divided by 2 times Eg minus f squared. And if you compute this, you get 0. Okay, so this is a minimal surface. Okay, in particular, helicoid is a minimal surface. Okay, sectional curvature, not section, scalar curvature is always 0. Okay, in the exam, I will probably give you all these formulas. I cannot keep those in mind, and I cannot expect you to memorize all this. I will give you the formulas, but you should know how to use them and so on, right? You should know which one represents the curvature, Gaussian curvature, which one represents the scalar curvature, and so on. So exam will be up to this point, including today's lecture. It will not contain the material I will cover on Monday. On Monday, I'll start and probably finish section 5.5, which is again, some computational techniques. In case your surface is given like this, okay, fxy. Then you have a special parameterization. What is your parameterization? You can choose your parameterization like this, uv, and then f of uv. And then all these formulas will be in terms of derivatives of f, okay? So it's just about that. So essentially it doesn't contain new material, but just all this material computed for this kind of parameterization. But I will not include that section to the exam. Okay. Sanırım bugünlük de bu kadar yeter.